Hello and welcome to another episode of the Prof series. For this episode, we'll be covering Dr. Steve Loewen. This man is a very impressive individual, in charge of breeding all the processing tomato breeding lines for Ontario, more or less. He's also the one that inspired me to take on as my primary field of study. Dr. Loewen, if you're watching this, consider this a shout out. Now on to the video. Breeders of horticultural crops and agronomic crops have been developing methods and strategies to breed different cultivar types through different methods of selection. Grain crops have a very specific means of measurement in terms of quality, and breeders have used collecting data in large populations to figure out this information. There's primarily three main traits that they look for: stability of the grain in the field in a large population that's highly dense, yield in the high-density population, and the ease of harvest. In contrast, horticultural crops require labor-intensive harvest, and the crop itself is far more perishable. Evaluation of a crop is often based on attributes beyond yield, with appearance, quality, and flavor playing major roles within the breeding program. This involves a more subjective hand on what looks better and what tastes better. This has been made more objective through the advent of genome-wide selection models and genetic markers. The trends in data regarding any crop is based on how the data is organized. The classification of fruit shape in tomatoes, the classification of disease resistance, and so on and so forth. Digital phenotyping has occurred where the measurement of these aesthetic traits are sectioned off to a software program. The program called Tomato Analyzer has made this process at least partially automated in nature. All crop improvement is grounded in the ability to withstand different environments, and the phenotype of a really good cultivar is also affected by the environment as well as genetic components. Within Ontario, however, there is a lack of a baseline data collection to see if improvement is actually happening or not. To that end, Dr. Loewen created a multi-location trial and a multi-year trial to determine trait variation between multiple different populations and subpopulations of tomato breeding line. Phenotypes are measured through Tomato Analyzer, yield is measured by the traditional means, and chemical tests of fruit quality were tested using different means. All traits are based on the Solanaceae phenotype ontology network. The cultivars collected were 143 processing tomato breeding lines, obtained from the organization SolCap. 95 of these lines were obtained from the Midwestern United States and Ontario, Canada. 26 lines were developed in Oregon and California. 14 lines were developed in Cornell, and the rest are from miscellaneous regions. The data was analyzed using the R software package. Based on the analysis, the Ohio lines had significant genetic correlations between soluble solids and acid quality. Color, shape, and size traits also seem to be correlated with each other as well. Total yield seems to be correlated with total markable yield. However, soluble solids were negatively correlated with yield, but positively correlated with acid quality. So in a sense, increasing quality decreases yield to a certain degree. The genes for size and the genes for shape seem to be correlated with each other, so breeding for certain sizes will change the shape and vice versa, which is to say that breeding for certain shapes will indirectly breed for size increases, specifically the size of the plant. When you breed for more circular fruit, you get a 0.46% increase in that shape, but you also get a 0.3% increase in height of the plant. Arid-adapted germplasm grown in humid environments has a higher color rate than those adapted to humid conditions. The same factors are found across all different groups, though. As a consequence, what could be applied to Ohio could be applied to California and Ontario. As expected from the study, most of the quality traits, such as flavor, color, and processing capabilities, alongside agronomic traits such as yield, are primarily quantitatively inherited. Dr. Loewen concludes that the breeding strategies within tomatoes should shift from its current form to a multi-selection model, known as an MTI system. These statistical models could be used to, if a model like that would be created, one can know how much selection can be done for each specific trait and how they are inherited, as several traits are correlated with each other, and when you breed for one trait, you're also breeding for another trait, as well as breeding against a third or fourth trait. So a model that takes this into account and tries to create a balance between these traits will be necessary going forward for future breeding options. It was also recommended that breeding work should focus more so on the genes responsible for the interaction between fruit color and the environment, and the genes responsible for hue. Selection in this regard would improve fruit quality quite immensely, since the majority of the variation seems to be in fruit hue and the interaction between color and the environment. So further breeding in the process of reducing the effect of the environment on color and increasing hue in general would improve fruit quality and increase marketable yield. And thank you for watching this video. If you enjoyed this video, please like and subscribe. If you really enjoyed it and think you can donate, you can do so at Buy Me a Coffee, link in the description below. Thank you for watching.